So, hello everyone. I hope you're all having fun in this event today. And yeah, I'm going to talk a little bit about how to host software reliably. And what I mean by this with software is like some kind of server component or like a web front end. Basically, like anything you can think of. It could also like be a game server. And when I mean host, I mean we want to have it running on like a VM, so a virtual machine or a dedicated server. We are renting or just having in the cloud. So there are multiple options basically. We could also have a hardware server, but I won't really go into this. Unfortunately, I can't be here live today. So if you have any questions, just feel free to ask me here. This is my Discord, and that's basically the best way if you want to ask anything to me directly. So, just a very quick note on me. I'm a DevOps engineer, and what I basically do is that I work with code and with servers at the same time. So I do admin stuff and I do code directly. So, and what this means is though that I'm working in this field, what I'm really talking about today, but I only have like some limited experience, I would say. In regards to what I'm telling you is something that works for where I work, and I think it works also for other companies, and it's rather modern. But it doesn't mean that it's the only way to do it. So it's just one way that works. So that's what I'm telling you about. So this talk will really reflect my own experiences and so on. So let's first ask, like, why might hosting be hard? And I think there are basically multiple reasons why hosting is hard. Basically, it is its own field. So it's very complicated and there are many things. And if someone is new to it, they probably won't know most of the things that are important here. And like you really have like much specific knowledge to doing administration and hosting stuff. And yeah, that's basically the main point, that this is like something you have to break into. And I feel like also that the reliability expectation, so how reliable should my system be? How reliable should this all be in the end? Can be kind of daunting. And yeah, basically it's where do we start? And the expectation and like the what has to be done is kind of difficult. So now that I mentioned reliability, let's talk about reliability now. So, and we can ask like different things about reliability. So we actually have many measures for reliability. So there is a very well-known one named mean time to failure. So this is the how long does it take until there's a failure, so until there's a problem from starting out. Then we have mean time between failures. So this is basically from problem A to problem B. How long does it take between the failures for another failure to occur? And this is also always mean time. So this is like some averaging. And then there's also a very interesting one, the mean time to repair. So this is the time how long a problem itself persists. So this is also another kind of very important part. Though this is these all kind of combine into like somehow reliability, but this one is probably a more very important one, as you this is your preparation part. So if you prepare for failure, you can fix the problem faster. But actually, if you look around, one of the most popular ones, at least in web applications, is the so-called uptime percentage. And the uptime percentage basically just means how much of the time is the stuff available. So this is basically just the problem time. So actually this time over all of time, basically we are looking at. So usually if we talk about this, we always have to give like some kind of time range. If we want to talk about like relay so now that I've talked about uptime rate percentage, what's the expectation for like some reliable system? So the expectation for a reliable system is then quantified in numbers. So for example, 9 is the 2 9s, and this is a 99% uptime. Then we have like 3 9s, 4 9s, and so on. And yeah, basically, if we look at these, for this, we can have like an out time of 40 minutes per day. This is 1.5 minutes per day. And this one is just 8.6 seconds per day. So you see really a big difference here. These were calculated using uptime.is, by the way. And to give like a expectation, the service Discord in the month of that I looked at, this is March. In March, had a reliability of 99.98 to 99.99 according to their own statistics within that month. So 1 month isn't really that much to look at, but yeah, just to give like a reference. And Discord is like, this is a big project, right? So this is like, it better be high if you look at Discord. Yeah. Let's say now we want to actually start hosting stuff. We need to decide on how we are going to do this. So basically there are many different technologies, and I'm just going to present some of them now. And the first case basically we are going to look at is a single server we are running. And in this context, we are currently now operating. So if you're on a single server, and let's say it's a Linux server, also have a little bit of Windows, of course, but we could run the stuff like with Screen. So Screen allows us to just directly run a process in the background on the system and go away. So this is just like a background terminal. But the thing is also, even though it has like maybe a little bit of logging and stuff, it's not really that like it doesn't really have like a restart function and so on. So if you would like to be a little bit more reliable and handle crashes of our stuff, you can use something like systemd. So systemd, this is the basically the standard service management on Linux these days, and it has stuff like automatic restarts. It has good logging, so you can really look at your program logs after they run. And you also have a good suite of utilities, so for process management, for example, if you want to look at the stuff you have here. And I would say, like, if you're using systemd already, this is already quite good. So, but still, this is directly running on the server. So in many applications, we actually want to abstract from the server we are running on. And for this, we have something called Docker. And with Docker, we can run like basically many virtual machines on one VM or one machine basically. And we have like can have every program like so often. So we can have like if you want to have like a Minecraft server, for example, just and then we have just another one and so on, and they will be completely isolated from each other in these kind of systems. And actually, we don't even have to install Java or something. Java is needed for running Minecraft on the main system because it's actually in these mini VMs of Docker. And this is really useful actually because you can pre-package these, and there are so many options, and download first, and also when you do it yourself and create these yourself, you can do so much to make your life easier. Now let's say we want even more reliability, and we don't want just like a single server, but we want like multiple servers. So we have like one here, we have like one here, and we want to run our software on all of them together. So just because we have multiple servers, it doesn't mean that they give us more reliability. You have to connect them together. And this is what we use Kubernetes for. So Kubernetes is basically a little bit like Docker, and can directly run like kind of containerized stuff. So like basically mini VMs, and many of them in its system, and it runs these on multiple so-called nodes. And this is basically the non plus ultra, I would say. So the best way to, or one of the best ways to host stuff, because this is a very resilient system in many ways. I mean, many things can go wrong, but this is like really good. And you have like tons of documentation. You have many options, but also it's hard to learn. I would say the other ones are much easier to learn and use, like, but this one is actually kind of hard, I would say, and you have people who have jobs who basically just do this, just do Kubernetes stuff in a company. But it's also, at these days, I would say, the industry standard to use this. And yeah, so this is basically like the endpoint. If you now think about this a little bit, and like so this is basically yeah. Also, just to be a bit more complete, I want to also mention serverless. Serverless is basically something you can do in the cloud. So most of these things run in the cloud, of course, but you just like upload a container and it runs. So they scale it for you, like make it multiple and so on. Or you have like some code you can write, like for example, Python code or so on. You can just run that directly edit in this kind of system of like a cloud provider. and then it will run like as a function basically. So this is a very different approach, but in the end they also just run their servers, and this is quite expensive, unfortunately. Although it can be also quite easy to start up after you get used to it. So for example, Amazon and Azure do provide these kind of functions. Okay, let us now think about these things, these technologies we discussed. We have screen, we have systemd. I will not put Windows stuff there directly. We have Docker. We have something like Kubernetes. And then you might have something like serverless. And basically, I want to like talk a little bit about like when to use what. So let's say you are just testing your application. Then I would actually directly just say, go with screen, just run it there directly. It's easy, it's useful, but don't stay here for long. This is just like testing only, I would say. After you're like done with like maybe some initial testing, I suggest to either look at Docker directly or systemd. Probably actually from here to there is easier to do, but this one can also be rather useful. So yeah, you have to learn how to build some Docker stuff. For this you need to learn how to make some service definitions. It's not too dissimilar, I guess, in many ways. Then let's say you're already using stuff like this for a long time. You are like now growing stuff and now you start needing more. Then I would say let's maybe go for Kubernetes. But it's important to note, this is a big time investment. So this one is kind of like when you notice that these things start to limit you, you go for this. And you can set it up yourself, but usually you just order it in the cloud. So serverless is a little bit out there. I would say this is a little bit of a special case because you really have to learn about how to use this kind of stuff, and it's a bit specialized. But I think it can be useful for like prototyping maybe. There are some people who do stuff in like all of their things here. I think it's a little bit can be a little bit too much because you have so many small things in the end, and might just be easier to organize them in another way, like using Docker and Kubernetes. So yeah, with Docker you have like also better control if you have like multiple systems together than with systemd, I would say. Although systemd also has like many things running in tandem. So it's more like an opinion from my side. We have these three things, and I would say these have two different curves associated with them. This is the reliability. And then we have the ease of use. And so that's basically why I'm recommending these both central spots here. So this is very, very good to learn because many companies use this these days. So this talk is a high-level overview of these topics and of this topic, and like should like be a guide on what to start working on directly without like exploring stuff you're not sure about. So basically, if I would now recommend you to do something to explore, get yourself some Linux server. Learn how to SSH into it. can also like run some local stuff and so on. There are many options, but I think it makes sense to like get a simple server. Then configure your server to use a firewall. Please don't forget this part. UFV, for example, UFW, and then can on the server start trying out stuff. So look into systemd. In general, systemd services, so service definitions and so on. There is good documentation for this. The other thing I would do is install Docker there. Just run some of your own containers, some of the public containers. Like get used to them, try to run some stuff basically, and then try to build your own container. So this needs a little bit of other knowledge. You have to kind of create a build file to make this, and then with your own containers you can like learn how to run your own software in Docker. And if you want to really learn like the deeper skills, and like if you really want to learn the skills for stuff like Kubernetes, you can then start to use something called Kind. Kind is actually running on Docker. So this is basically Kubernetes in Docker. So this is the shorthand. With that you can start using it, and then you interact with Kubernetes cluster using kubectl, and this can directly interface with Kind. So kubectl is the important part. But this is like such a broad topic. Yeah. But if I would recommend something, try to use your own container and run it in your Kind cluster as a pod, where pods are the unit within Kubernetes clusters. So yeah, this is basically like how to get started and with hosting software reliably. And these are basically different level options, and I hope you have some point to start at now and to start to look and to test out for yourself. So yeah, as I said, any questions, you can send them to me on Discord. And with this, enjoy your time and drink some tea.